Hello everyone. Congratulations on making it till this point in this course. This is the final lecture, which is concluding remarks, where I will be briefly talking about the different aspects which are discussed in this course. This course, titled Introduction to Infrastructure Asset Management, is offered under MOOCs, an initiative of Government of India. I would like to thank the Government of India for this initiative, IIT Kanpur, all the teaching assistants, the students, project staffs, the media team, and everyone else involved in creating this course. With that, I'll quickly talk about what are the different aspects we have discussed in this course. In this course, we started our discussion with understanding how infrastructure plays a key role in the socio-economic development of a country. We saw that developing countries like India have been spending heavily on infrastructure construction. But along with construction, it is also important that we manage our infrastructures well, because any civil infrastructure deteriorates with time. There are issues like corrosion, sulfate attack, and so on. So it is prudent that we manage and maintain our assets well. In the initial discussions, we saw that an asset manager needs to come up with an asset management plan which is sustainable, resilient, adaptive to climate change, data backed, and also we need to keep in mind that we keep a life cycle perspective when taking this strategic decision. In this course, we started with understanding what are different infrastructure assets, what is the life cycle of an asset, who are the stakeholders involved. Then we moved towards understanding what is assets performance and why do we need to maintain and preserve them. Then we discussed a generic framework which can be used for any asset management process. We discussed the different aspects of data collection, performance modeling, decision making, and so on. Within the data collection, we addressed the aspects of determining the role of data in infrastructure asset management. We talked about different data requirements, different types of data. We also discussed different aspects of how to prioritize data, how to handle missing data, and so on. Then in the next segment, we saw how the data which is collected can be used for performance modeling. Here we saw that a sigmoidal performance curve is typically used to define performance. We also saw that with time, if we don't do any maintenance, the performance of an infrastructure asset goes down, and we need to take appropriate actions to preserve the life of an asset. Then we moved towards development of alternatives, where we discussed different maintenance techniques like no maintenance, preventive maintenance, light rehabilitation, medium rehabilitation, and so on. We saw that for any infrastructure, throughout its life cycle, we have several options. At any given time t, either we can decide to do no maintenance, or we can decide to do preventive maintenance, light rehabilitation, or a heavy rehabilitation. We also saw that it is not a one-time decision. We need to have a maintenance strategy so that the asset's performance can be preserved throughout its life. Building on this discussion, we moved to the next aspect, which was decision making. In decision making, we discussed different aspects of the need to do economic decision making, where we saw that we need to keep in mind the life cycle perspective, life cycle cost, as well as the life cycle environmental impact. Then we saw that there are multiple criteria under which one needs to take a decision. These criteria are defined by the different policies and goals of the agency which is managing the asset. Also, we saw that the decision has to be a multi-objective problem which is comprehensive. We need to take a decision on which infrastructure needs maintenance, when does it need a maintenance, and what type of maintenance it needs. So we saw that this problem has to be solved at the network level, where we are deciding which asset needs treatment, when does it need it, and what is the appropriate type of a treatment. Moving on, we saw that these decisions are often governed by three key goals: the goals around performance, sustainability, and resilience. We discussed each of these aspects in detail and saw that performance can be defined by different aspects like availability, reliability, maintainability, safety and so on. Also, sustainability is a three-legged problem which includes economics, equity and the environment. Also, we discussed different aspects of resilience like robustness, redundancy, rapidity, resourcefulness and so on. Thus, there are performance, sustainability and resilience goals. An agency maker needs to take a decision keeping all of these in mind. But we also saw that some of these objectives are often conflicting in nature. Moreover, in this course, we have highlighted the fact that whatever analysis or decision we take must be from a life cycle perspective. Life cycle cost as well as life cycle environment, both of these are important aspects, and in taking any of these decisions, we have to stick to the available budget. We have also discussed what is the difference between budget planning and budget programming. So, we saw that once we have a decision, we move to the next step of implementation and monitoring. So, this is the generic infrastructure asset management process which was discussed. This process is generally applicable to any infrastructure. Along with this, we also dived deeper into more specific details around concrete. How does concrete deteriorate? What are the different non-destructive testing methods? How do we monitor concrete and so on. With that, I would like to hand over to Professor Sudhir Mishra for his concluding remarks.
Namaskar everyone, taking over from where Professor Chirag left. We've talked of concrete assets, the design and their deterioration in the overall framework of infrastructure asset management. I have repeatedly said that concrete structures are being used only as a case. Once you understand this story here for concrete, you should be able to apply them for any other structures that you may encounter. So, now what was our thrust? The thrust was that there is environment here, we have concrete cover, we have steel bar and then the main concrete inside. The idea as far as design is concerned is to ensure that our main concrete has a certain strength, and as far as durability is concerned, we somehow protect our reinforcement. And we considered two mechanisms, carbonation and chloride penetration. These two are most common as far as the threat to the reinforcing bar is concerned. So, what we said was we need to take steps to ensure that this carbonation depth does not exceed the cover or maybe stops a certain length before the cover in the service life or during the service life of the structure. Similarly, when it came to chloride penetration, if this was the chloride penetration level, here we are talking of chloride concentrations inside the concrete over a period of time. So, what we have to ensure during design is that the cover concrete has properties which are basically diffusivity or permeability, or whatever you call it, something like that. That should be such that the extent of chloride concentration at the location of the reinforcing bar does not reach the chloride concentration. This is at the time of design. During the inspections, what we have to check is that what we expected at different points in time during the service life is the chloride concentration or the depth of carbonation, is that more or less compared to what we had anticipated. So, basically as far as this course is concerned, we try to define a deterioration versus time graph, we try to define a performance versus time graph, and the idea was deterioration increases with the passage of time and performance decreases as a passage of time. And as far as this concept of service life is concerned, we can define it in terms of either the deterioration, that okay, the deterioration should not exceed this value. So, therefore, this becomes my service life. It can be defined in terms of performance, that if this is my critical performance level, this becomes my service life. So, if both are defined, then the lesser of the two will become my service life as far as that particular structure is concerned. So, that was the overall theme under which we operated. So, to recapitulate, what we did was spend some time on these deterioration time graphs and examining the concept of service life and maintenance action in that framework. And let me add that this performance versus time graph that we have been talking about is actually the same as the sigmoidal graph that was talked about earlier, where also the change in performance over time has been represented using mathematical functions. We tried to talk about case studies which highlighted the role of different stakeholders in different phases of the projects, importance of comprehensive strategies towards management of these assets. We talked about decision making frameworks including performance modeling considerations in budget allocation. We talked about corrosion of reinforcement as induced by carbonation or chloride penetration. Then we spent some time relating the quality control at the time of construction to the deterioration and specifications to the initial performance, that is these values here. And in the final module, we talked about inspection, evaluation and repair action, and we tried to define rigorously what the kind of repair action can be in light of these graphs. So, basically what we tried to do as far as this course is concerned, we said okay, here is a performance versus time kind of a graph. We had these terms scheduled service life, design service life, remaining service life, and we talked about repair retrofitting at different points in time, and we tried to say that okay, this was the predicted performance, this is the actual performance and so on and so forth. So, within this framework where we try to understand performance and deterioration changes over time, we tried to explain to you the whole concept of management of infrastructure assets. So, this picture here is just a flow chart of that thought process, where we say that we start the initial inspection at the end of the construction process, and then through periodic inspection, detailed evaluation and so on, we try to understand the deterioration causes and the degree, and then we try to do repair and reinforcement as may be required. So, with this we come to an end of our discussion. And by the way, for the sake of completeness, I must also add that though the discussion in our course has been limited to civil engineering structures, we have talked about concrete, we have talked about reinforcement, we have talked about bridges, roads and so on. The discussion is actually generic and can be extended to other parts of infrastructure, maybe mechanical engineering, electrical engineering. Those of you who have had experience in maintenance functions in, let us say, a power plant, even if what you are maintaining is mechanical systems, it could be machines or whatever, you would be able to relate that the idea that deterioration increases over a period of time and the performance decreases, that is more or less similar. Different disciplines and different areas have their own way of looking at these deterioration and performance graphs and having their parameters which quantify them. And finally, on behalf of Professor Kothari and myself, we would like to express our thanks and gratitude to all our teachers, colleagues and students who in my case over the last several decades and Professor Kothari's case just the last few years have contributed directly and indirectly to our understanding of infrastructure creation and maintenance. Some of the slides we have used have been included with their permission. Though Professor Kothari has already thanked the NPTEL team, the studio staff here and all these people who have helped us as a team to record and edit all these lectures. We would also like to express our thanks to Tanya, who has been instrumental in maintaining a lot of schedules as far as these recordings are concerned. Thank you everyone, and we look forward to seeing you at another time, possibly in another course.